All right, today we are going to go over the second day of 9.2. We're going to take what we learned yesterday and add the fraction part of it. Now don't freak out, fraction part is not hard. It'll be easy and pain-free. But first, let's go over an example of what we did yesterday. We did number 1 and number 2 in our notes yesterday. So in case you weren't here, I'll just go over them quick again for a quick review. We have the square root of 75. Some of you might have done the factor tree. I think the majority of people used finding the perfect square root that goes into it. So in this case, we could take 25 times 3. And when we do that, 25 is perfect. Its square root is 5, so that comes outside the radical sign, so called outside of the jail. And we have 5 times the square root of 3. Done, because everything inside here is done. And we did 80. You could do 80. Some of you yesterday started out and you did 4 times 20, which was fine. And then 4 is a perfect square, so the 2 breaks out. So then we have 2 times the square root of 20. However, you're not done because there's a factor within this radical sign that is still perfect. And if you break that down, you would have 4 times 5. The 4 here is still perfect, so square root of 4 is 2. All right, and then we still have the 5 left in here. Now we had this original 2 from up here. You have to multiply these. 2 times 2 now is 4 times the square root of 5. And that's your final answer. Quick review from yesterday. Now we take that knowledge and apply it to what we're going to do today on day 2, adding the fraction part of it. So let's just go right here to example 3 in your notes. Now notice the jail sign, the radical sign, is around the whole fraction, 17 over 25. These are so simple. All you need to do is rewrite those with a jail sign, with the radical sign around the numerator. So you have the radical sign around the 17, make them separate, and then the denominator, you put a radical sign also around the 25. All right, so now you have a radical sign. Now they're treated separately now. You have a numerator and now you have a denominator. And this is where your number 2 and 3 rules come in on that first page when we did our vocab. You are not allowed to have any radical signs in your denominator. And then on all the problems that you're going to be doing, all your denominators will be perfect squares. Okay? So if you want to do that first, do the denominator first, because that's usually the easiest part, because those are always going to be perfect squares on your homework. So the square root of 25 equals 5. Done. There's no square root sign anymore in our denominator. The mistake that some people will do, they'll say, oh, the square root of 25 is the square root of 5. No, you can't. It got out of jail. It is now just the 5. So you just put the 5 for your denominator. We got rid of the radical sign. Now 17, however, the square root of 17. If I did the factor tree for it, it would just be 1 times 17. There are no perfect squares that go into it because 17 is prime. So basically 17 is done. So we just rewrite that as our numerator, the square root of 17. That is our simplified answer. I cannot simplify that anymore. That's what your answer will look like. And that is basically fraction form. Pain-free. So fractions aren't as scary as you thought they were going to be. Let's do another one. First thing you need to do. Okay, they have the jail sign. They have the radical expression over the whole fraction. Rewrite that with the radical sign in the numerator and the radical sign over the denominator. Equals. Now let's simplify. Let's do the denominator first because that's always the easiest, since I told you that they're always going to be in your homework. They're always going to be perfect. So they break out of jail. The 9 is perfect. Its perfectness is 3. So the square root of 9 is 3, so now our denominator is just a 3. No radical sign in the denominator. We're rocking it. We got it. Now the square root of 5, can I simplify that anymore? No, it is prime. So we rewrite the numerator as the square root of 5. I have my new simplified answer of the square root of 5 all over 3. Done. That's all that we can do on that one. Number 6, rewrite that with a radical sign in the numerator and the denominator. Write it in your notes. So the square root of 21 over the square root of 64 equals the denominator first. The square root of 64 equals 8. So now we went from 6 square root of 64 is now just an 8. 21, are we just going to rewrite that as the numerator again? Well, 21 is not perfect. 21 is not perfect. What are its factors? We could go 3 times 7. Is 3 perfect? No. Is 7 perfect? No. So once again, we cannot do anything to the square root of 21. It's as simplified as that one is going to get. Okay, there's 3 more examples that I want to go over with you before you start on your homework. Let's do this one together. You have the square root of 49 over 100. First thing we do is, yes, rewrite it. We need to rewrite that. So we have the square root of 49 over the square root of 100. I'm going to do the denominator first. That equals the square root of 100 equals 10. Now the square root of 49, ooh, life is easy. Is that a perfect square? Why, yes it is. So the square root of 49 equals 7. So my answer is 7 over 10. 7/10. And that is my final answer because I can't simplify 7/10 anymore. It's already in simplest form. If it would have been, say, 8 over 10, our final answer, well, then I could have simplified that again to what? Divide by 2, you would end up with 4 over 5, if that were to be the case. All right, next example. The square root of 54 over 36. First thing you need to do, rewrite it. Square root of 54 over the square root of 36. Boards out. Hold up your answer and see if it matches mine. I will give you about 30 seconds. Go. Okay, we'll see if your answer on your board matches the correct answer. Do the denominator first. It's a perfect square. The square root of 36 is 6. 54, not a perfect square. However, this can be broken down to 9 times 6 So the 9 can be broken out. 3 is its perfect square, and I still have 6 left inside. So my numerator now becomes 3 times the square root of 6 all over 6. Now, technically we're not done with that one. No, the 6 and the 6 can't be crossed out because this is inside the jail. That's all left all by itself. But look at this fraction, 3 over 6. We can simplify that. 3 goes into here once, 3 goes into here twice. So now even a better answer is 1 times the square root of 6, that's my numerator, and my denominator is now 2. All right, so 1 times the square root of 6 over 2. And in some cases, you wouldn't even need this 1 here. It would still be the same answer. There's not a lot of problems like this one. However, if you were to leave this 3 times the square root of 6 over 6 on your homework, I possibly, depending on test or quiz what I've given you, I might take 1 off. Otherwise, if you simplify it to this, I might end up giving you a bonus point. Depends upon what the test or quiz is all about. All right, last one we want to do together. Square root of 27 over 64. I'll give you 30 seconds to come up with your answer on the board to see if it will match mine. Okay, eyes up here. For those of you that if you're still stuck, don't panic. Let's go through it. All right, I'm going to do the easy part first. The square root of 64 is 8. All right, now the numerator, 27. No, it is not perfect. Any of its factors perfect. Well, I can take 9 times 3 and get the 9 is perfect. Bring out the 3. So now I have 3 times the square root of 3's left in jail here. And I am done because on the outside 3 over 8, that's already simplified. I can't simplify that anymore if you're looking for a bonus on that one. Here is your final answer. All right, you may start on your homework.